right, welcome to the 9-5 notes. I'm only going to have you do the front side of these notes because they can be tough. You do have to remember a lot of prior knowledge on how to solve simple equations, both linear and quadratic. So I cannot stress enough that this video needs to be paused a lot. You need to take your time to understand where these numbers are coming from and the reason I'm doing the steps the way I'm doing them. You also should be pausing the video and trying the questions before I do it. You have a lot of knowledge that you have to just apply to these questions. So try to think through it, maybe talk to the person next to you to see if you can figure out what you would do before I tell you what to do in these videos. Okay? So you just finished the 7-4 notes. And so all of these questions that I'm going to be working on are logs. And we talked about there's two different ways to solve logs. Turn it into the exponential or set the arguments equal. Okay, but you can only turn something into an exponential if you have a single number to be the exponent, and you can only set the arguments equal if you have a log on both sides and there's nothing else in front or behind the logs. So let's take a first look at this first one. It already kind of explains what you should do. Solve each of the following equations for all values of x by first combining the logs. We have to combine these because right now I see 2 logs. If I put the log on the other side, I would still have the 3. So I can't set my arguments equal since that 3 is there. So I need to try to get it down to a single log so that I can turn it into exponential. So you have to remember your properties. If it's a subtraction property, pause and try to write this in a single log. Okay, now if it's a subtraction, you should be dividing things. So we should have 3x plus 23 divided by x plus 1. That's just using the property from the subtraction. Now, it is a single log, so I get to do option 1 of turning this into exponential because I know the base of 2 to the power of 3 is equal to the argument. So the way that I'm going to write this is the base of 2 to the power of 3 equals the argument, 3x plus 23 over x plus 1. So 8 equals 3x plus 23 over x plus 1. Now, how do you remember how to solve a linear equation like this? Okay. Okay, well, that's actually not linear, but you don't know that yet. But when there's an x plus 1 in the denominator, you can think about it like cross multiplication if you turn the 8 into a fraction. So if you think about it like cross multiplication, you multiply the diagonals, which just give you 3x plus 23, but you have to multiply the 8 and the x plus 1 together. So 8 times x plus 1 is 8x plus 8. Make sure you distribute that 8 to both things. And then I'm just left with 3x plus 23. Okay, so now I get to solve it just using simple inverses. So I get x to be 3. And again, it should make sense when you substitute it back in that log base 2, when I substitute 3 in, 3 times 3 is 9 plus 3 is 32 minus log base 2, 3 plus 1 is 4. This should equal 3. Okay, and it does when you work it out, but it makes sense. Okay, pause this video, try the next one. You will have to remember quadratics. Okay, I really hope you tried. Did you try it? If not, you can work through my steps. Okay, I have to combine this because there's a plus. So I have to remember my property that plus is actually multiplication. So when I multiply x times x minus 3, it does have to get distributed to both. So it is going to become x squared minus 3x equals 1. This is a common log question, so there is a base of 10 that's just invisible. So now that I have a single log, I can turn it into exponential. Base to the exponent equals the argument. Anytime you have a quadratic, you need to set it equal to 0. So if I set this equal to 0, I get x squared minus 3x minus 10. You will have to remember how to factor to be able to solve some of these questions. Because to solve by factoring means I need to figure out what times what is negative 10 that adds to negative 3. So that's negative 5 and 2. And when I solve it, I get x to equal positive 5 and x to equal negative 2. Okay? Now, this is something that hasn't come up yet, but I'm going to check it. When I do log of 5 plus log of 5 minus 3 of 2, is that equal to 1? Yes. But when I do log of negative 2 plus log of negative 5, right away I should notice, uh-oh, argument is negative? That's not good. Thus, this is an extraneous solution. So remember, we cannot have no negative arguments. Just like when we had those exponentials, we couldn't have a negative argument, so we had a no solution. But since there's two possible solutions here, I would end up getting extraneous solutions. Okay, so you will have to check your answers every single time. Okay, so sometimes we're going to have to use our properties. Same thing goes over here. We have to use a property first, but after we use the property, let's see what happens. So I use my property to combine these of multiplication, so I get 9x goes log base 2 of 45. Now it's option number 2. Set the arguments equal to each other because my bases are the same. So this is a nice easy question. X should be 5. So some of these are nice and fast and easy. Some of them are going to require a lot more work. Okay. Try B. Pause it here and try it. Okay, I hope you tried this before coming back to my answers. Don't just copy down my answers. You're never going to learn it if you don't try it. Okay, so right now I'm using the property subtraction equals division. My logs are the same on both sides, the bases, so I can set them equal. Now I multiply by 3. So I get x to be 7. I checked it. Log of 15 minus log of 3 is the same thing as log of 5. Okay, so in all of these cases, I'm still using both possibilities of how to solve a log, turning it into exponential or setting the arguments equal. But I have to use my properties before I can start. Okay, so on these next three questions are hard. These are the last 3 questions of the notes. So I want you to just try. Try them, please. See what you can come up with. See what mistakes you may have made so that you can learn from your mistakes and not just copy down what I do. Come back after trying these to see what you can do. Okay, on this one, there's a lot of logs going on. I first see this 2 that's in front. A lot of people like to try and divide it by 2, but then you'd be dividing things like this, and that's just like, why do you want to have it divided by 2 over there? So that's just not going to work for us. So we don't want to divide. But I need to remember that any number that's being multiplied by a log can also be written as a exponent. Okay, So this is the same thing. Log base 4 of x squared minus log base 4 of 2 equals log base 4 of 18. I see my subtraction, so I do want to combine it so that it's a division problem now. X squared divided by 2. I have nothing else on either side besides the log, and those logs have the same bases. So now I get to do the option where I set my bases, set my arguments equal, excuse me. When I multiply by 2, I get 36. When I take the square root, I get x equals, not only do I get positive 6, but remember when you solve with an even root, you also get negative 6. I need to see both of these answers because the 6, if you plug it in, works, but if you plug in the negative 6, 2 times log base 4 of negative 6 doesn't work. So this is an extraneous, and I need to see it. I need to see all extraneous solutions. Okay, these next two get harder. Quadratics come in. You have to remember how to multiply and how to solve. So try it. Did you get the gist that I'm trying to have you solve these before you listen and watch my video? I hope so. Okay, it's addition. I gotta multiply. Logs base 6. If I multiply 2x plus 3 times 4x plus 5, that's going to be 1. You have to remember how do you multiply that. Some people FOIL it, some people use the box. But either way, you have to know how to multiply this. Okay? So this ends up being 8x squared plus 10x plus 12x plus 15, still equal to 1. That is what you get if you multiply it using the box or if you FOIL it. I'm simplifying it down a little bit. 8x squared plus 22x plus 15 equals 1. What could I do from here? I still have a log. How do I get rid of the log? This is where the base to the exponent equals the argument. So the base of 6 to the exponent equals the argument. How do I solve this? This is a quadratic. What do all quadratics need to be equal to before you can start? 0. So I have to subtract my 6 over. I get 8x squared plus 22x plus 9. How do I solve this? Best way to do it? By factoring. Could you use the quadratic formula? Absolutely. But the best way to solve this is by factoring. You need to know how to do the box to get your factors. So 8x squared, 9. What multiplies to 8? I'm going to try 4x and x. Okay. I also need it to be, that doesn't make sense, 4x and 2x. And then I need the numbers to be 9. So let's try 3 and 3. 3 times 3 is 9, 6x and 12x. Diagonal does not equal 22, so that doesn't work. So let's backtrack all of that. Okay, now what if I try 9 and 1? 9 and 1, 4x, 18x. Oops. The diagonal equals 22, so that does work. So my two parentheses are 4x plus 9, 2x plus 1. I have to solve both of these. So I get negative 9 over 4 and negative 1/2. Now, a lot of people think these are both negative numbers, so they're both extraneous, but that's not the case. It's all about substituting it back in. So when you substitute it back in, the negative 9 over 4, log base 6, negative 9 over 4 is negative 2.5. So if you multiply, do you get a positive or do you get a negative? Negative 2, okay, plus 3, you end up getting a positive, so that's fine. Then, same thing. But when you do the negative 1/2, when you do log base 6, 2 times negative 1/2 is negative 1 plus 3. Okay. Oh, I said the wrong thing over here, by the way. This ends up not working. Sorry. This is a negative. Negative, so this won't work. Okay, but over here, this one will, because when I do negative 1 plus 3, this is 2, so that's fine. And when I do negative 1/2 of 4, that's negative 2 plus 5. This is 3, so that's fine. So this works. This is an answer. Negative 9 over 4 is not an answer. So be very careful. Negatives don't mean extraneous. Negative arguments mean extraneous. Okay, that was a long problem. My voice hurts. I hope if you need to, go back to any of these steps. If you need to ask anybody at your table why the steps worked the way they did, ask. Okay, if you need to write down a question so that you remember to ask me on Monday, write it down. Okay, but you have one more question to do, one more question to try before I come back and do it. Pause me, because I'm getting sick of hearing myself. Try it and then come back. Okay, right away I see a log on both sides. I cannot set the arguments equal to each other because this 1 is here. There's something blocking me from doing the arguments equal to each other. So the only other option is I have to get a single log on one side. So if I have to get a single log on one side, I have to move the log to the other side. Okay? So to move the log to the other side, since it's positive, I need to subtract the log. And subtract it on this side. Okay. Now that I'm subtracting log 3x minus 4 minus log of 2x plus 3, subtracting on the left side is actually going to turn this into a division problem, because when I combine my logs to a single log, the subtraction turns into division. So it's going to be 3x minus 4, 2x plus 3. Now that I have a single log on one side and a number on the other, I can turn it into a base to the exponent equals the argument. Base to the exponent equals the argument. So now I can multiply both sides by 2x plus 3. It divides out on the right, and I'm left with 20x plus 30 equals 3x minus 4. 17x equals negative 34. X equals negative 2. Check it. Does it work? Log negative 2 times 3 is negative 6 minus 4. Uh-oh. This is a negative. This doesn't work. This doesn't work. If the only answer I get doesn't work, it's a no solution. Okay, so you have to see the importance of showing your steps, showing your extraneous solutions, checking your answers, and writing no solution when it's no solution. Okay, so in all of these questions, you still did one of these two methods of turning it into an exponential or setting the arguments equal. You just had to do a few things first. You had to combine things or move things around before you could do that. Okay, this was a lot. I'm sure your brain hurts. My voice hurts after talking this long. Write down any questions that you have for me on Monday. so that we can go through these questions on Monday, and we will continue the backside. If you want to try the backside, great. But we will do the backside together on Monday. Okay, backside Monday, review everything Monday. Then yes, next Wednesday will be a mini on all aspects of solving. Okay, thanks for watching. Thanks for taking your time. Have fun doing the circle competition. Make sure you guys judge each other's appropriately. Thanks, and have a great weekend.